Select all of the shapes that will carry onto themselves after a reflection along the dashed line. So to carry a figure onto itself, we've also referred that as mapping a figure onto itself. So that means that the dashed line there, the line of reflection, also has to be a line of symmetry. So if we were to fold the shape along that line, it would look the exact same on the top of the line as it does on the bottom of the line, or on the left side of the line as it does on the right side of the line. So if we look here for the first one, for this blue shape, it's very obvious that this line of reflection is not a line of symmetry. So folding the shape along this line would not map the figure onto itself, because the part of the shape above this dashed line does not look exactly like the part of the shape below this dashed line. The next one here, this is a little trickier. So if we were to reflect this green shape across this dashed line of reflection, at first glance it might look like it would map the figure onto itself. But we need to look at these congruence markers on our sides. Here, this side has 2 congruence markers. If we were to fold this green shape across this dotted line, this side where I have my yellow part circled would end up here. And you can see in this part of the figure, that side that it would land on top of only has 1 congruence marker on it, meaning those 2 sides are not congruent, and this green one does not carry on to itself when you reflect it over this dashed line. The next one is a square, so we have our line of reflection here, and we could see that if we were to reflect this square over that line of reflection, it would map onto itself. The left-hand side of the line of reflection is the exact same as the right. Down here, the pentagon would also map onto itself or carry onto itself if we were to reflect it over this line of reflection, which means that line is also a line of symmetry.